Lesson K9, Measurement Using Radians. So first thing we're going to start off by asking is, what is a degree? Well, we've been measuring in degrees for a while now, so you should know the answer to this. 1 degree is 1/360th of a circle. So on your screens you should now see a depiction of how large 1 degree is. Not very big at all. But we use it to measure our arc lengths and angle measures. Today we're looking at something new though. What is a radian? A radian is the angle made when the radius is wrapped around a circle. So it's another way of measuring angles, but we do measure it differently than degrees, and we'll talk about how we can find radians from degrees. So 1 radian is about 57.2958 degrees. Converting between radians and angle measures. To change from degrees to radians, we multiply by pi over 180. To change from radians to degrees, we just do the opposite. We multiply by 180 divided by pi. Measurements in radians are usually written in terms of pi. This is really important, so please underline this in your notes. We always want to leave our radians in terms of pi. Measurements in degrees are usually rounded to the nearest tenth. So going through with this lesson and these notes, please round to the nearest tenth. So first we're going to start off with 27 degrees. Now remember, to change from degrees to radians, we multiply by pi over 180. So when I multiply 27 by pi over 180, I get 3 pi over 20 radians, or 3/20th times pi radians. We'll continue on with the degrees and then we'll move on to the radians. So 150 degrees, again, we multiply by pi over 180, and we get 5 pi over 6 radians. Now 180 degrees, if we take that times pi over 180, well, the 180s are going to cancel out, and we are left with pi radians. Now let's try going the opposite way. Let's go from radians to degrees. So 3 pi over 4 radians. We want to multiply that by 180 over pi. Easiest way to probably remember which direction or where to have the pi, whether in the numerator or denominator, is in degrees. We don't have a pi. So we need to if we're going from radians to degrees, we want to multiply by 180 over pi so that our pi's cancel out. So 3 pi over 4 times 180 over pi gives us 135 degrees. If I have 2 radians, so there's no pi in this one, we're going to have to approximate. So 2 times 180 over pi gives us about 114.6 degrees. Pi over 2 radians times 180 over pi gives us 90 degrees. Finding arc length. For a circle of radius r and a central angle of measure theta, that's what this Greek symbol is here. This is theta. So for a circle of radius r and a central angle of measure theta in radians, the length s of the intercepted arc is s equals the radius times theta. So arc length equals radius times theta. So here we have an example where circle F has a radius of 5 inches, and the angle formed by the radii in the diagram has a measure of 2 radians. Well, I just need to take my radius, 5, times theta, which in this case is 2 radians, and I can find the length of the intercepted arc S. So 5 times 2 gives me 10. So the arc S is 10 inches long. Let's try a couple more examples. So again, using the formula where it's radius times theta, to find the length of arc S, I would take my radius 3 times theta, which is pi over 3. My 3's cancel out, leaving me with pi. And again, we want to approximate. So S is approximately 3.14. So for this second one, my radius is 8, and theta is 3/4 pi. So again, we substitute in as needed, and we multiply. 8 times 3/4 pi gives me 6 pi, or approximately 18.8. Finding angle measures. Find the measure of the angle shown below. Leave your answer in terms of pi. So we're going to use the same formula that we just used, but this time we are given the length of the arc and the radius, and we need to find theta. So again, we're just going to substitute in what we know. I know S, my arc length, is 4 pi. I know my radius is 6. So I have 4 pi equals 6 theta. I divide both sides by 6, and I get 2 pi over 3 is equal to theta. After you get an answer, you can also convert it to degrees. So remember, when we're converting to degrees, we take theta, our radian measured, times 180 over pi. So 2 pi over 3 times 180 over pi gives me 120 degrees. Area of sectors. The area of a sector in degrees is theta divided by 360 times pi times r squared. Pi r squared, remember, that's our area of an entire circle. So again, a sector is just a portion of our circle. The area of a sector in radians is theta over 2 pi times pi r squared, which is also equal to half pi r squared times theta. So using that formula, half pi r squared times theta, let's find the area of the sector with a radius of 7 at a central angle of 2.5 radians. So again, we substitute in what we know. So I have half times 7 squared, because 7 is our radius, times 2.5, because that's theta, and we get 61.25 square centimeters. So let's try one more example. We have 2 more examples. Find the area of the sector with a radius of 5 inches and a central angle of pi over 2 radians. Again, substituting in what I know. I have half times 5 squared, because 5 is the radius, times pi over 2, because pi over 2 is our radians, and I end up with 25 pi over 4, which is fine, you can leave it in terms of pi, or approximately 19.63 square inches. So for our last one, a sector of a circle with radius of 10 has an area of 50 square centimeters. What is the angle in radians at the center of the sector? So this time, we're not finding the area. We want to find the angle in radians. So this time I substitute in 50 for my area and 10 for my radius. So I have 50 equals half 10 squared times theta. From here I get 50 equals 50 times theta. Well, if I divide both sides by 50, 50 divided by 50 just gives me 1. So theta equals 1 radian.